Hi everybody. Okay, so we have been talking about angle relationships for the last few days, and today I wanted to do a video with you where we talk about those angle relationships and then pull in the algebra that we were learning at the beginning of the year. So for each one of these, the first thing we're going to do is identify the angle relationship and write a kind of shell of an equation, and then we'll fill in the stuff. What we have to be careful of when we do problems with algebra in them is we don't want to get overwhelmed when we see the algebra, right? So a lot of times people understand angle relationships. For example, they can look at this and say, I know what I see here. I see vertical angles here. And I know about vertical angles, right? I know that vertical angles are congruent. And so if I can get my pen to write, I know that A equals B. And I can write that and I'm good to go. But then when a problem like this comes along, we get thrown back a little bit because it's got all this stuff, right? And I don't want you to let that stuff confuse you, because you know about vertical angles, you know that they're congruent, and you know how to solve equations. So this problem doesn't need to overwhelm you. All right, so I want to show you some strategies today for how I get these solved and how we kind of can take the algebra out of the mix in order to get our equation set up. All right, we want to focus on the geometry first and the algebra later. So the first thing that I'm going to do is I'm going to grab my highlighter. You should be able to do this in your Schoology assignment too. I believe you can mark up your diagrams. And I'm going to highlight the two angles that they have labeled. So in this picture, they have this 32-degree angle labeled. That's of interest to me. And they have, oh boy, okay. And they have this other angle labeled, and in it they have this, algebraic expression. Now notice that they have a 9x plus 5 there, and it's complicated even more by them putting parentheses around it and then putting the degree symbol after it. Oh my goodness, I'm a mess right now. Lordy help me. Okay, I'm back. All right, they complicated it even more by putting parentheses around it and a degree symbol. You can kind of ignore that. The only reason that's there is because they're indicating that it's the measure of an angle, and angles are measured in degrees. Right? So they're being really, really specific and making sure that you know that that algebraic expression right there, that 9x plus 5, the whole thing refers to how big that angle is. So if that angle is 42 degrees, then 9x plus 5 is 42 degrees. Okay, so that's why they put the parentheses around it, and that's why they put that little degree sign on it. But that's not really important to us in solving the problem, so we're not really going to mess with it a little bit. Not mess with it. Here we go. Look, I need an equation. The question we're going to ask ourselves, other than why my computer is running so freakishly slow right now, is oh my, okay. First thing we're going to ask ourselves is, what is the relationship between those two angles that I just highlighted? In other words, I've got a blue angle and a green angle. What's the relationship between the two of them? Well, if you look at the way they come together, you can see that this diagram is a heck of a lot like this diagram, right? These are vertical angles. They come together at the crisscross of an X. Well, guess what? These are too. So here's what I know. That green angle, that green blob, has to be exactly equal to the blue blob. It's a pretty good equation I wrote there, isn't it? Blue equals green. Okay. But the fact is, the way I labeled up my diagram, that's exactly what's true. The angle that I highlighted in blue is equal to the angle that I highlighted in green. So once I've established that relationship, all I got to do is bring down the way they labeled their angles into my equation. So in my blue blob, I'm going to put my 32. What is happening? Gosh, Miss Tibbs is probably like, Miss Britton, get it together. Your technology. Okay, and in my green blob, I have a 9x plus 5. And again, I'm not bringing down that parenthesis, and I'm not bringing down that degree sign. What? Okay, this is getting interesting. All right, so look, once I have my equation written, this is an equation that we could have solved weeks and weeks and weeks ago. This is what we spent the beginning of the year working on. This is a DCMCS equation. That's all we got to do is solve it. The geometry is done. The geometry of this problem is recognizing that you have vertical angles and being aware that vertical angles are the same, that they're congruent. Once that's done, the rest of this is algebra. All we have to do is solve this equation out. Okay? So if we follow DCMCS, there's no distributions to be done, nothing to combine on the left, nothing to combine on the right. The very first step we have to do is a move step. Okay, now I think I'm going to be a little bit lazy here. Usually I like to put my letters on the left, but then I would have to move more things. So I'm going to be lazy. I'm going to leave my letter on the right hand side here, and I'm going to move my numbers to the left. So if I take 5 off of both sides, 32 minus 5 is 27. I'm left with 9x over here. So that's my move and combine. And look what I'm down to. After one move and combine, I'm down to my last step, which is my solve. And that solve step is always the same. We divide by the number that's in front of x. We divide by the coefficient of x. So I end up with x equals, on this side they cancel, 27 divided by 9 is 3. And we got it. Now look, I can go up here and check that. 9 times 3 is 27, plus 5 is 32. 32 equals 32. We got it. Okay? Jeez, oh man. All right. These ones are the ones we're used to seeing, right? These A, B, simple ones. These are the ones we've been doing the last few days. All we're doing now is adding this layer of algebra to it. The relationships are the same. The equations are the same. They just look more complicated, but they're not actually more complicated. All right, let's look at this one. We had a vertical example. Now let's look at these two. We're used to seeing this stuff now. Here's a right angle, which means the angle on this side is also a right angle. So we know, as geometry majors, that A and B must be that complementary. Right? In other words, if I take A and B and I add them up, I'm going to get 90 degrees. Okay? And we're good at that. Now, look at this next problem. It's got algebra in it. Looks funky, but it's the same thing. Look at that. I still have a right angle, and the two angles that I'm interested in are just like A and B. They're the two angles that make up that right angle. This problem is exactly the same as this problem. The only difference is how the angles are labeled. They're labeled in what looks like a more complicated way. All right, so let's grab our highlighter. I'm going to use yellow this time. This angle, yellow, and I'm going to color way out here so I can grab that 2x plus 6. And my coloring is superb. Okay, so I have a yellow blob. And how about a purple blob? My other angle that they have labeled. And again, the reason I'm labeling or coloring these particular angles is because they're the ones that are labeled in the diagram. So they're the ones that we know that whoever wrote this problem thinks are pretty important. I don't know what's going on with my computer, but my yellow blob disappeared, and that is not cool. Okay, so let's get our pen out here. What do I know is true about my yellow blob and my purple blob? I know that just like these angles over here, these angles have that same relationship. They're complementary. So all I have to do is say, hey, yellow and purple, I know about them. They add up to 90. And then I wait and see if my computer is going to respond. Goodness. Okay, so again, look, these two come together to add up to 90. All I got to do is plop these numbers down here. My purple blob is 48. This was funny for a minute. It's starting to not be funny anymore. Okay. My yellow blob is 2x minus 6. Honestly, what is going on? What? So now I have an equation. And again, if it makes you happy to write it without the blobs, it might be easier to look at. Okay. So when I take DCMCS to this one, I don't have a distribution, but I do have some combining that I can do. So if you look here on the left-hand side of the equation, I have a +6 and I have a -48 that can be combined. So 46 minus 6 is 42, right? So I still have a 2x, but instead of a 48 and a -6, I'm going to just combine them and put a +42. Okay. Now that I've done the combining, it looks like I've got no more combining that can be done, but I have some moving and combining that can be done. So I can take this 42 to the other side. I end up with 2x equals, let me do the subtraction right, 48, 80, 90, yes, 48. And then finish it off by dividing by 2. So I get that x equals 24. Okay. Let's go up here and see if we were right. If x equals 24, then this is 2 times 24. What on earth is happening in my life? That's 2 times 24 and then -6. So 48 minus 6 is 42. If I take 42, which is this angle, and 48, which is this angle, and add them up, I sure get 90. And that's what we knew in the first place, that these two have to add up to 90. I said that in the diagram. Okay. So that tells me two things. I wrote the right relationship and I solved my equation right. Okay. If you write that these two add up to 90 and then you get a number down here, but that doesn't make them add up to 90, then you made an algebra mistake. Okay? Let's do one more. The linear pair. What if I told you guys that I already did this question and my computer stopped recording and I was talking to myself for a while? Yeah, but don't worry, I'm back. Okay, so look what we have here. We have these two angles, A and B, that are coming together to make one full arc or a 180-degree angle. We call these supplementary, right? And we know that if you take A and B and add them up, you better get 180 because between the two of them, they make this whole big arc. All right, so let's look at a problem like this that has algebra in it. Okay, and let's use our highlighters for fun. I'm going to make this one Christmas themed. All right, so I have this. Just kidding, I need my highlighter. Okay, I have this really big angle right here that they're calling 138 degrees. I like that. Nice, neat number for me. So that's my green blob. And I have this angle over here, this smaller one, that they have labeled as 2b plus 8. So I have a red blob. Okay. And again, by looking at their relationship, I know they are supplementary because the two of them together make up that whole big arc, and we know that that whole big arc is 180 degrees. What on earth is red blob? Thank you. Okay, ready? Let's see if I can solve this without my computer messing up. When you mark it, set, go. All right, so I know that these two angles add up to 180 degrees. So if I take green blob plus red blob, it's going to equal 180. And let's just give my computer a minute. Oh, see, you should have known what's going to happen. There we go. Okay, so green blob, 138. Are you serious, computer? red blob. Now my mouth isn't even working. 2b plus 8. Disappeared. Okay. Here's my equation. 138 plus 2b plus 8 equals 180. So if I look at DCMCS again, I have the same situation that I had in my last problem. And this is a pretty common thing when you add two things up and get 180 or get 90. A lot of times you do end up with a combination on this side. It's pretty standard. Okay? I have two numbers over here. So there isn't a distribution, but there is a combine. I have two numbers. I can combine 138 and 8 to get 146. So I have a 2b and I have a 146. Okay? That's going to equal 180. All right. There's nothing left to combine over here, nothing left to combine over here. So let's go on to move some terms around. I need to move this 146 so that it can be over here on the right hand side with this 180. So I'm going to do my opposite operation. The 146 was being added, so let's subtract it. I don't want to be smug, but I'm on a computer roll here. Okay, over here they cancel. 180 minus 146, so let's see, 180 minus 140 would be 46 more, 34 is my mental math answer here. Okay, so 2b is equal to 34. Finish it off is my solve step. I just have to divide by 2. Okay, so b is 17 because 34 divided by 2 is 17. All right, and again, if we go up here to the top, 2 times 17 is 34, plus 8 is... See? I had to say something about being on a roll. 2 times 17 is 34, plus 8 more is 42. If you add 42 to 138, you get 180. So we know we're right. Okay, so when you go into Schoology to do your assignment, you're going to see some really straightforward problems that are like the problem here on the left, just an A and a B. You're going to see some problems like we're in the Quizlet, where it's like an A and a 42. And you have to figure out if they add to 90 or if they're equal or if they add to 180. You're also going to see some problems like this. My goal for you is that you not be, that you don't quit when you see this, right? You know the geometry and you know the algebra. You know how to do DCMCS and you know these angle relationships. These problems are just marrying the two. And everybody loves a good math love story, especially me. All right, so if you watch the story in class, which you were supposed to, then that means there's plenty of time for you to come back and ask questions, and I am waiting for you. So if you have any questions on this, come back into class, ask me your questions, get them answered. Then you can go do the Schoology assignment. Okay. If you're good to go on this and you want to go start the Schoology assignment, head over to Schoology. It's due by the end of the day on Friday. Okay, I'll see you later. Have a good day.